1S1. Any unit in District 2, Zone 2, having a chainsaw and some availability to help out one of our own, please?
It's clearing my 38. I'll be on a 1019 to HCF.
Utah 214642, priority 3.
Code 2 for a 1055 no contact well-being check on one of
Code
our
this
own.
location. Could I have a unit 1025 with me for Code 2? Bring in some water.
Alright guys, time for an update. So I'm going to take a little time here to show you the latest enhancements of the MSX 100 controller. That's the new Storeford repeater controllers, the custom ones designed for the PEG radio system. The end results is probably going to be something like this, where we have flange mounts to mount easier mounting on any surface, as opposed to the other ones that don't have that. This particular one is a Wi-Fi version. It's got a Wi-Fi antenna, but they'll be available in a non-Wi-Fi version, which I think will be a bit more cost-effective. It also has some connections here for external relay control. Those external relay boards, this is probably the one that we would use, with a simple pigtail here, can be connected to here. And this would work as a relay control board that you can control 4 individual 10 amp loads. You can either can be momentary or it can be latched, and you also have the capability of utilizing the normally open, normally closed, and common contacts on this board. So that'll come in handy if you wanted to switch anything with the controller. But on a totally different note, I'd like to show you some of the latest designs that have finally worked its way into getting updated into the firmware. So now the controllers actually perform the way they were designed. There's only really one other major thing that I have to do in the very near future, is to do the testing on the special link modes that the repeaters have the capability of doing. I won't get into that now because it's a bit complicated. Okay, so these two radios represent, or 3 radios, represent 3 radios that are operating in the same zone. And if you remember earlier, I did comment on the Q-tone concept. On a Category 3 multi-zone system, there are 2 Q-tones. A high-pitched tone, which is 1000 Hz, and a low-pitched tone, which is 500 Hz. A high-pitched tone essentially represents that the person that is talking is inside the same zone as you are. A low-pitched tone indicates that the communications that you're about to hear is outside of your zone. I'm going to show you. All of these radios are in zone 3, so when I key up, you'll hear a high-pitched Q-tone on all the other radios. 1, 2, 3, 4, 5. 1, 2,
3, 4, 5.
Again, if I key up, you'll hear the high-pitched tone. 5, 4, 3, 2, 1.
5, 4, 3, 2, 1.
Now, if I take this portable here and I switch it over from channel 3 to channel 2, now watch what happens when I key up on channel 2. Because channel 2 is outside, it's not in the same zone as these. I'm going through the zone 2, which happens to be right behind me over here. When I key up, you're going to hear the low-pitched tone out of this radio instead. That indicates to these units that the communications that's about to come through is outside of their zone. It's not in zone 3, it's in any other zone. Again, if I transmit on 2, which is outside these zones, you'll hear the low-pitched tone. If I switch this radio back over to channel 3 and I talk, you're going to hear the high-pitched tone because I'm in the same zone. Okay, so I want you to see what this looks like on the controller now. Okay, so as I transmit, I'm going to show you the flow here. I transmit on zone 3 radio over here on my bench. It gets received by the low band radio. Then 2 things happen simultaneously. The node controller sends out a Q-tone. So basically, this radio goes from a receive state while it's receiving me immediately to a transmit state to transmit the local high-pitched Q-tone on the node itself. As that's happening simultaneously, the link radio is transmitting to the repeater. The repeater radio essentially receives it. The moment that this controller detects this repeater radio receiving it, it too sends out a low frequency tone to every other zone. So that's where the low frequency tone is coming from. It's coming from this repeater controller. Again, I'm going to transmit on channel 3, which will get received by this. The Q tone will go out. You'll see this radio goes immediately from receive to transmit back to receive in order to send the transmission of the Q tone out, then come back to listen. So I'm going to transmit on this portable radio on channel 3. 1, 2, 3, 4, 5. 1, 2,
3, 4, 5.
And you can see what's happening here. If you look closely, you can see that port 1 begins to receive. As it receives, it transmits a Q tone, and it immediately starts forwarding it out on a port 2, which of course is this radio here, the link radio. Sends it over to the repeater starts to hear it, sends the Q tone on. You can see the lights indicate that. I'm scratching on the grill, you can see the audio, and I'm going to let go of the PTT. Now it comes out of here, gets received by the link radio, you can see that here, and forwarded back out onto port 1. The reason why I'm showing you this is because I did have some questions about what would happen if the main repeater would go down. If the main repeater would actually go down, it would essentially stop the entire system from functioning, because the repeater is responsible for, it's the hub essentially, and it links all the systems together. Well, there's a special code that we can type in. I'm going to show you on this portable, I guess. If we type in 100 on this radio, what it does is it completely converts this node into a self-contained repeater. So say this repeater, I'm going to show you. I'm going to disconnect power from the repeater controller as if the power went out at the repeater site, or it got hit by lightning or something. Now watch, if I transmit on channel 3, you're going to see that it never repeats because this repeater is down. 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Nothing happens because it's doing its job. It's taking the low band traffic from the zone and forwarding it over the link radio, but since there's no repeater, it can't repeat it back out and go through the system backwards. So when this scenario happens, we dial in 100 on the node. What it does is it tells the node to completely reconfigure itself for self-contained repeater operation. And at the same time, it also notifies users that this is actually happening. I'm going to show you an example. I'm going to type in 100 now. Now that the repeater is down, I'm going to convert this node into a full-blown self-contained repeater. And this can be done on every node in the system.
Attention Rhode Island RIPEG user groups. The RIPEG radio system has been temporarily placed in a special operating mode due to a technical condition at the main transmitter site. In this mode, communications will therefore be limited to the residing local zone and not statewide. Repeating. The RIPEG radio system has been temporarily placed into a special operating mode, restricting communications to be limited to the local zone only. Additional information will be provided as it becomes available.
So that message goes over. Now the system has already been configured automatically. It's a series of about 25 different configuration settings that get changed in about less than a half a second. So right now, that message just went out notifying everybody in the zone that the system is not actually functioning as a network now. It's functioning as an individual node repeater. Now you'll watch, if I transmit on channel 3 now, remember that this was trying to forward it over to the repeater, but watch what happens now. Now it becomes a self-contained repeater. Check 1, 2, 5, 4, 3, 2, 1.
Check 1, 2, 5, 4, 3, 2, 1.
See, now it's doing its own thing. It's as if it is a repeater. Now to get it to convert back, I simply type in 200, it'll convert it back.
Attention Rhode Island RIPEG user groups. The radio system has been restored to its normal operating network mode at this time. Repeating. The RIPEG radio system has returned to statewide network status at this time. No further information is necessary.
Now if I plug the power back into the repeater as if we restored power, or we went to the repeater site and we repaired it, now you'll see that all of the nodes can be put back into normal operating mode, which means that they won't function as a repeater. They will forward all of the node traffic over to the main repeater, which will essentially link the entire system back up again. Check 1, 2, zone 3 network check.
Check 1, 2, zone 3 network check.
So now it's fully functioning as a system, as a network system. A few of the other things I want to show you is that we can make custom messages for each PEG system. Since we have multiple groups using our system here, we have multiple messages for different groups. For instance, if one of our dispatchers needs to put out a call for our United Civil Emergency Services Agency, our rehabilitation services, if we key up a radio, or the dispatcher keys up a radio, and dials 911, we get a special toned out message that triggers all the pagers.
Attention, United Civil Emergency Services Agency, E3S personnel, stand by for a priority 2 incident dispatch.
Now the dispatcher would actually do the dispatch. Since the system, like I said, is also used by other groups, including the Rhode Island preparedness community, we have other messages, such as, I'll show you. If we dial 411, we get a different message.
Attention, Rhode Island RIPEG personnel, stand by for general radio notification traffic.
So that's a general notification traffic for everybody on the system. We also have 211. Nope.
Attention, United Civil Emergency Services Agency personnel, stand by for general radio notification traffic.
So that's notification traffic just for UCESA, or United Civil Emergency Services personnel. These messages can be custom recorded and custom script. Now, when those tones are put in, essentially what's happening is it's telling the controllers, it's telling these controllers to run a particular script that's actually stored on the repeater itself. Along with that is also a WAV file. The WAV file is professionally recorded here at my studio, and these can be sent out and custom made for any application. Now I'm going to show you on the computer. Let's zoom in here, and I'm going to show you what's going on the computer as to what's actually in the controllers when we plug a USB plug into the back of the controller. Alright, so a closer look here. I'm going to plug in the repeater controller, the main repeater controller, the red controller actually, into the computer. This is an Ubuntu Mate computer. So the first thing that happens is you'll see it opens up the drive of the actual repeater controller, and these are all the files that I had stored on this controller. Now there'll be standard files that when you buy a PEG controller, one of these MSX controllers, they'll have a certain default files on here. But I want to show you some different sides to this. If you recall a minute ago, I typed in the 211, 911, and 411 commands. These are right here. The macro 211, anything with a macro, an underscore, and a number, that number indicates, or that is what the DTMF pad will respond, or it will cause the controller to respond to that code. So let's take a look at one of these scripts. If we take a look at the script itself, you're going to see that the first thing the script does is play an alert tone, so it gets everybody's attention. The tone indicates that it's at 1,000 hertz, and that's at 2,000 milliseconds, which is 2 seconds. The next thing it does is it plays, or it's told to play, the UCESA general notification wave file. And that general notification wave file is right here. Okay, so that's the next thing it does. Then it plays a series of alert tones, and then the dispatcher would actually put out the information. Now, this is the case with all of these. Any macro file is a file, like I said, that will play with DTMF. Now we can access these commands directly by opening up a terminal. In this case, I'm going to be using a terminal program called Putty. And this right here represents the actual terminal to control the controller itself. Let's take a look here. So if, just say for instance, you wanted to play a tone manually to do some testing, and you wanted to do, say, a 400 hertz tone at 2 seconds, and you hit enter. Okay, it does that. Now say we wanted to run one of these scripts manually. Instead of dialing in 2 or 411 or whatever, we could actually just run macro _ 411 CMD, and it'll play that script.
Rhode Island RIPEG personnel, stand by for general radio notification.
We look at the script as it's playing. See, here's the tones right here. This is everything it just did in succession. This is a macro file, meaning that one command can set up a series of commands almost endlessly. Comes in really handy. Okay, so that's that script right there. Now, if we type in show, it will show you the various settings here. The settings are, right now, the transmit level's at 1000, that's nominal. Transmit port number 2 is at 1000, and it goes all the way down and shows the different portions and all the different settings and configurations that can be done. If you say you wanted to look at the Q tone, you can actually type in QT time, and it'll show you the time duration of the Q tone that goes out on this system, which is 550 milliseconds, just a little bit over a half a second. If you wanted to find out the Q tone frequency, it's 500 hertz, and if you wanted to find the destination of where the Q tone is firing, you type in Q tone dest, and it'll show you that port 1A goes to port 1A. Port 1B also goes to port 1A, and so on, and it goes right through it. And this is pretty much configurable 100% by the actual terminal. But naturally, you're not going to have a computer terminal tied to this controller, so obviously having this stuff available on DTMF scripting is really important. So you can see the massive power of the systems and what you can accomplish by simply doing script files. And again, these script files can be somewhat complex, so I can, these can be customized and set up for your group individually. But anyway, I just wanted to brief you on some of the latest changes to the system, and I also want to show you later on, I'll show you the actual testing that's going to be done for the multiple link modes that these repeater controllers are going to be able to do. It's actually the first of its kind to be able to link multiple Storeford repeater networks together. It's very complicated in the way that it actually functions behind the scene, but in terms of user functionality, it's very easy. It's basically just as simple as typing in DTMF codes on the actual microphone, if you had a microphone like this, or you had a portable that had a DTMF pad on it. So anyway, that's just the one of the latest updates, I should say, about the new controllers. And I got a lot more to follow up on, but I just wanted to show you at least the latest and greatest upgrades to the firmware.